Math 102, example 2.8.1. So we've seen how to solve quadratic equations. So now let's do some applications, story problems. All right, so here I'm going to make a rectangular region. So let's start by drawing a rectangle. But here we're going to use a barn as one of the sides. In other words, I'm not going to put fencing there. So I'm going to label just the other three sides because I don't have to build anything on that fourth side. So that 120 feet of fencing, again, anytime we talk about fencing, that's generally perimeter. Now, usually the perimeter is 2L plus 2W, but again, I'm only using three sides, so it's just going to be 1L plus 2W. Let's solve that for one of the variables. I'm going to do L just because L is a little bit easier. And then what is it that I actually want? I want area. So area, that is still going to be length times width. So let's take this expression and plug it in here for L. To get A equals 120 minus 2W. Again, I write that instead of L. And then I have the other W as well. Let's distribute that out. And I'm going to rewrite this so that the W squared term comes first, just to make things a little easier to see. Now that is a quadratic. We can see that pretty clearly now. And if we check our problem, we are actually looking for the maximum area. As we hopefully remember from a previous section, the maximum occurs at the vertex because this parabola opens down. So again, anytime we're asked for a maximum, we interpret that to mean find the vertex. So our equation for the vertex was negative b over 2a. So here b is 120 and a is negative 2. And dividing that, I get 30. Now, that is in W, so that is my max width. To get the actual maximum area, let's plug that into my equation. And then at that point, I would just plug that into my calculator, and we should get 1,800, and that is in square feet. You could also find both the length and the width, and do length times width is area, or if nothing else, you could do it both ways, and use that to check your answer.